Hey everyone, and welcome back to another sensational science video. Yes, smaller gap this time. Yes, let's get in. Anyway, as I said, we are going to be doing a new series about the solar system. The first episode being the sun. Now, this is obviously it can be quite a simple topic, but when you look into more detail of it, it's more complicated than you might think. So this is going to be an in-depth video about this star that we're orbiting right now. Okay, let's start right now. Why not? Obviously, we know that the Sun is the star of which 8 planets, including Earth, orbit. It's a yellow dwarf currently, but after 5 billion years, it will turn into a red giant when it runs out of hydrogen to burn and when its core shrinks. But we'll go into more detail about that later. The Sun is 4.6 billion years old, and the surface temperature of the Sun is just under 6,000 degrees Kelvin. However, the core temperature is a lot hotter, 15 million degrees Kelvin. And the Sun is also brighter than 85% of all of the stars in the Milky Way. Admittedly, though, most of them are red dwarfs, so yeah. So the Sun is currently made up of, mostly hydrogen, which is basically 73% of it, and the rest of it is helium, which it's got fused into. And other elements include oxygen, carbon, neon, and iron, and other stuff as well. 600 million tons of hydrogen is fused into helium every second, and 4 million tons of matter is turned into energy every second as a result. So 99%, to be precise, 99.8% of all of the mass in the solar system is made up by the Sun. And in case you're wondering, the picture on the right is actually partly the Sun's true colour, because although it is a yellow dwarf, it's actually more on the white side in terms of its colour. Now the Sun has several structural stuff, and we're going to go through that now. The core, the bit in the middle, obviously, 20 to 25% of the Sun's radius, and that's where nuclear fusion happens. It's hydrogen into helium. This process releases energy in the form of heat and light, and eventually, after a long time, helium will gradually fill up in the core, but we'll go into more detail about that later on in the video. Radiative zone is the bit just after that. Energy transfer is done here by the means of radiation rather than by convection, and that's done by the convective zone, but once again, more on that later. The tachocline, I think that's how that's pronounced, is a small section between the radiative and convective zones. It's very, very thin, so probably don't need to remember that too much. It doesn't even say that on the diagram. But anyway, the convective zone is a section where the Sun is actually relatively cool compared to the rest of the star, and is the primary source of heat transfer. The photosphere is the deepest part of the Sun, which we can actually observe with visible light, probably using a telescope, obviously, though. The atmosphere is a gaseous halo surrounding the Sun, comprising of the chromosphere, solar transition region, corona, and heliosphere. These can be seen when the main part of the Sun is hidden. So that's, for example, during a solar eclipse, which is, well, I think most people know what that is, but I'll explain. It's basically when the moon comes in line between the Earth and the Sun, meaning that the ring, but it's basically all you can see of the Sun is a ring. And next is the corona, and don't get that mixed up with the virus that we are currently suffering in. If you want to know more about that, you should probably click on the pop-out banner in the top right, and then you can see more about that. Anyway, this is an outer atmosphere where It's basically made out of plasma. It's several thousands of miles long, and it transports solar winds. Life phases. So the first bit, obviously, formation, is the time when the sun was born, is by a giant molecular cloud, sometimes called a nebula. This is made out of gas, and mainly hydrogen and helium, once again, because those are the lightest elements in the periodic table, and dust as well. Once a shock of energy goes through the cloud, the particles begin to gather together and heat up. Then a protostar is formed. This will continue to collect particles and will eventually start nuclear fusion. Now, as we go into main sequence, the formation will allow the star to build up in terms of heat, in terms of size and luminosity. So, from the beginning of its main sequence section, it will have expanded 15% in radius and 48% in luminosity. Now, as we come to death of the star, the sun will not go supernova like larger stars. Basically, it still needs to be 9 times bigger, roughly, and basically instead what happens is that when the hydrogen supply starts to run out, the core will shrink and will basically fill up with helium instead, and the gravitational potential energy will get released, causing the star to increase its size and luminosity and turn into a red giant. It will probably engulf up to Earth in terms of the planets that it will affect, and after this it will shrink into a white dwarf, which is ever so slightly bigger than Earth. And there are rumours, in fact, that the Sun used to be part of a binary star system. So the second star was called Nemesis, theoretically. It was either a red dwarf or a brown dwarf, which is technically not a star even. Brown dwarfs are basically like massive Jupiters, but they don't really burn. When I say burn, they don't really fuse hydrogen gases. But anyway, it orbited the Sun at a very, very large distance, so roughly 1.5 light years, which is basically 95,000 AU, roughly. And because of this large distance, it did actually break free and burned off into the depths of space. So, goodbye, Nemesis. Anyway, hope you enjoyed this video. If you did, please give it a like. Make sure to subscribe to the channel if you are new to science and want to know more about any scientific topics. You can let me know in the comments about what you want me to go into depth with, and make sure to share this channel, share this video, and I'll see you guys next time for perhaps another video about a part of the solar system. Until then, see you next time. Goodbye.